As Earth becomes ever more crowded, our eyes turn to Mars as a new frontier for humanity. But how will astronauts survive in such a barren world? In today's video, we are going to explore NASA's groundbreaking strategy for extracting one of life's essentials on the red planet, water. Here's the lowdown on how scientists are gearing up to explore the red planet. They're planning to drill into Mars to extract water and soil resources, hoping to uncover more about the resources lurking beneath its surface. But let's not take this lightly. Drilling on our neighbour in the solar system comes with its fair share of challenges. History of water discovery on Mars. Back in 2008, the Phoenix lander made headlines by touching down on Mars and confirming the presence of water, although it's in vapour or frozen form. This discovery got everyone talking, but it also raised some eyebrows. See, if there was water on Mars at some point, it might not be hanging out near the surface anymore. Nowadays, it's bone dry up there, and even if there is water, it's probably not our typical H2O. It could be acidic, for all we know. But the Phoenix didn't stop there. While digging into the Martian soil, it stumbled upon ice, caught a glimpse of snow in the Martian sky, and found evidence of clay and calcium carbonate. Then came MAVEN in 2013, swooping in to study the formation of Mars's atmosphere. Scientists were hoping to uncover more about its ancient atmosphere, turbulent history, and of course, the possibility of water. But what did they find? Well, MAVEN's observations suggested that certain atmospheric escape mechanisms might have led to the loss of oxygen and hydrogen, the major components that make up water molecules. But here's another thing. MAVEN wasn't designed to detect water ice on the Martian surface. Instead, it hinted that ancient waters on Mars might still be lurking underground, possibly trapped as ground ice or ice deposits. NASA and Honeybee Robotics collaboration. Over the past decades, satellites have detected ice beneath the surface of Mars, sparking a collaboration between NASA and Honeybee Robotics to extract water and other sources from the Martian surface. But it's not as easy as you think. The water has frozen to such an extent that the surface layer with a consistency that is similar to cement, making it a formidable obstacle for even the most powerful tools. Imagine a high-tech ice fishing expedition, but instead of fish, we're after Mars' hidden ice deposits. Here's how NASA and Honeybee Robotics plan to drill into Martian soil, melt the ice and pump it out using the Redwater Robotic Drilling System. Redwater Robotic Drilling System. Enter Honeybee Robotics, the California-based company that's taking on this daunting challenge. They've introduced the Redwater Robotic Drilling System, specially designed for the task at hand. This innovative system features a large, cold-weather drill capable of penetrating up to 25 meters deep, reaching the ice layers pinpointed by satellite observations. When it comes to developing the Redwater Robotics Drilling System, testing is the name of the game. Honeybee Robotics pulled out all the stops by setting up a large chamber that simulated the bone-chilling temperatures of Mars. They didn't stop there. They even recreated the Martian soil and added ice to mimic the real conditions. By doing so, Redwater has ingeniously combined two current drilling technologies into one. They're using the coiled tubing method to create a hole and employing the Rodwell approach to pump the water. Coiled tubing. The coiled tubing method is a sophisticated approach that involves a continuous length of steel pipe with a drilling head at its base. As it penetrates the Martian surface, a series of rollers guide the tube downward, steadily pushing it deeper into the ground. The drill head itself boasts a motor for driving the drilling process and a compressed air system to whisk away any debris that might clog up the works. However, on Mars, this technique has its limitations. It's effective for drilling through soil layers but encounters a drawback when it encounters ice layers deeper down. Scientists anticipated this, foreseeing that coiled tubing could only take us about 20 meters below the surface before hitting these icy barriers. That's where the need for a second drilling method comes into play, called the Rodwell approach. Rodwell approach. Here's how the Rodwell approach works. First, a small hole is drilled at the top of the ice layer. This precaution ensures that there's no soil underneath, minimizing the risk of contamination. Next, a short distance is drilled into the ice to create a stable roof for the water chamber. This chamber is formed by recirculating heated water, which melts the surrounding ice. The melted water is then pumped out to maintain the volume in the well. Finally, the goal is to establish a stable well, similar to those found on Earth. The ultimate goal of scientists with these methods is to create a reliable water supply for future human colonies on Mars. The dual-purpose functionality. The drill is ingeniously designed to be mounted onto a rover, taking advantage of the rover's large deployable solar panels to meet its electricity needs. These panels provide ample electricity for all operations, from drilling into the Martian surface to heating ice and pumping up water. But what about fuel for the drill itself? Here's where the Redwater robotics drilling system truly stands out. Redwater can operate using two different fuel sources. First, it can harness compressed air available on Mars, making it a self-sustaining system. Alternatively, it can utilize rocket fuel components derived from the water it extracts. This dual-purpose functionality is truly groundbreaking. Not only does the drill extract water for immediate use, but it also produces hydrogen rocket fuel as a byproduct. The drilling operations on Mars are aimed at revolutionizing space exploration by securing water resources while simultaneously producing hydrogen rocket fuel as a valuable byproduct. This dual-purpose functionality makes the system entirely self-sufficient, paving the way for sustainable exploration and potential colonization of the Red Planet. With this innovative approach, future missions to Mars can rely on locally sourced resources, reducing the need for Earth-based supplies and enabling longer duration missions. What do you think living on Mars would be like? How important is it to find water? Let us know in the comments. The quest for Mars is more than a journey, it's a bridge to our future in space. By understanding and supporting these technologies, you're part of this incredible adventure. Hit the like button and subscribe to Fact Me In to join us as we unlock the mysteries of the cosmos, one discovery at a time. Thank you for watching.